If we ask a small question to ourselves today, is the idea of sustainability important to us? An immediate answer would be yes. This answer is simple, but it needs intense research because this question poses multiple global challenges on all aspects of life in the contemporary times. To remain sustainable, we have to learn to meet our needs of today without compromising the needs of tomorrow. Good morning. I am Lipika. On behalf of IIIT Bhubaneswar, I welcome you to explore this contemporary global challenge in the research conclave, emerging technologies for a sustainable tomorrow. Sustainable tomorrow means transition today. Let's initiate this transition in this research conclave organized by International Institute of Information and Technology, Bhubaneswar. The purpose of this conclave is to provide ample opportunity to explore conceptual frameworks to embrace larger transactions that are required today. Along with this novel purpose, we have a glaring occasion to host a conclave to celebrate the remarkable day significant to the history of IIIT Bhubaneswar. We feel proud to share with you that on this date in 2014, we received university status by the government of Odisha. And for the first time in this decade, we are here to celebrate this great achievement. This was crucial and much needed. And this initiative is taken by our guide and mentor, Director IIIT Bhubaneswar, Professor Ashish Ghosh. What our mentor visualizes is not just a celebration of this status, which was conferred on us a decade ago, but a beginning of a new era of knowledge, creation, and dissemination. What can be a better way to celebrate this prestigious accomplishment than in a conclave? Now the research conclave at IIIT Bhubaneswar is enriched with three purposes: celebrate our glorious past, initiate promising collaborations, and create a platform to explore the potential of technology to bring about a sustainable tomorrow. For a sustainable tomorrow, let's inaugurate a promising transition today. And to do the honors, today we have us esteemed dignitaries from across the nation. Let's take a moment to welcome the honorable dignitaries onto the stage. May I please invite Director IIIT Bhubaneswar, Professor Ashish Ghosh, to please come on stage. I take extreme pleasure to invite our guest of honor, IIT Bhubaneswar, Professor Shripad Karmalkar, onto the stage. May I please invite our guest of honor, Sri Devesh Das, Technology Practice Leader, Bhubaneswar, onto the stage. I'm truly honored to invite our chief guest, Shri Tushar Kanti Behra, Honorable Minister, E&IT, Sports and Youth Affairs, Home Government of Odisha, onto the stage. To offer a warm reception, I request our students to present flowers to the esteemed dignitaries and please felicitate them. I must take this opportunity to extend the warmest welcome to all the participants of the conclave from across the nation. We wish you a promising start for now and a great career ahead. May this conclave open potential opportunities for you all. Today, your presence brings in the vibrations of energy, hopes, and ambition to our campus. The Research Conclave now feels like a knowledge festival. Thank you for being with us. We treasure your participation in the conclave. I'm sure together we will make this event a grand success. A huge round of applause for all the bright participants here with us. Welcome to Research Conclave 2024. To mark the official inauguration of the event, let's light the lamp of knowledge. We will have a small real lighting ceremony to invoke the blessings of the Almighty. I would like to invite our dignitaries on stage to please do the honors. Let the lamp burn bright. Let the lamp flame our curiosity to learn more. Before we start our educative sessions, let's take a moment to cherish our glorious past and take pride in our roots. I request our students of the music band group to present Utkal Vandana. Thank you. That was wonderful. Now, may I please invite the brain behind this initiative, our mentor, guide, director to the Iiit Bhubaneswar, Professor Ashish Ghosh, to please come on the dais and give us the welcome address.
A very good morning to all. It gives me immense pleasure to welcome you all to this research conclave. I see a completely filled auditorium. It's really very much pleasing for me, very much enlightening for me. My heart is full to see that such a great participation is coming up. Maybe most of you know that this institute was established in 2006, but later on this was converted to a university status, unitary university status in 2014. And this is the day, 20th January 2014, when this institute was converted to a unitary university. And that gave us all sorts of facilities like design our course curriculum, offering independent degrees. At this moment, this institute offers BTech, MTech, as well as PhD programs. We have more than 1,500 students, mostly from undergraduate courses. We have a couple of master's courses and a number of PhD students. This institute is established under the Electronics and IT department. So the institute is aimed to do a good research, to handhold the state government for spreading IT education in different parts of Asia. We have our Honorable Minister, Sri Tushar Veda, who is very active, is very energetic, very young. He is the MIC of a couple of departments. He is the Minister in charge of particularly our department, Electronics and IT department. In addition, he is holding other portfolios like Home Ministry and Youth and Sports Affairs. So this shows that how active and how energetic he is. He is managing 3 key departments simultaneously. Let us welcome him with a big round of applause. Next, we have the Director, Iiit Bhubaneswar, Professor Kalmankar, who is one of the top scientists in India in one of the very popular recent topics or recent research initiatives, is nanoscience. Maybe all of us know that nanoscience is very popular now. In addition, Odisha government is taking up a big step in Odisha for Silicon, as all of us know. So he is going to be one of the key persons, particularly for this sort of topics. So let us welcome him. Next, we have our guest of honor, Mr. Devesh, who is heading the IBM Group at Bhubaneswar. IBM has opened a new center in Bhubaneswar, and he is heading that group. He has a vast experience in working in many countries on many topics. So we'll surely listen from him about his knowledge, his experience, how to kind of carry on IT technologies in real life industries and so on and so forth. Let us welcome Mr. Dash. So we have our three big dignitaries sitting on the dais. We have a couple of more dignitaries sitting on the first rows. Professor Devdutt Shit is there, our registrar is there, Mohan is there, and my colleagues all are there. It's really a great pleasure for me to see all of you very much active and participating in this research conclave. As Lipika pointed out, this is the 10th year of the university status that this institute got. To celebrate that or to mark that, to commemorate that, we thought that okay, this would be a nice idea to do a kind of program for this particular day, to celebrate this day. And it was our colleague Dr. Arun Shahu who came up with the idea to have the research conclave. So Arun, along with two more junior faculty members, Deepak Kumar Raut and Sharthak Padi. These are the three people who worked very hard. I'll say the idea came up just maybe 2 weeks back. So just 2 weeks they took to bring this conclave to this extent. So I am really very proud of them. They did a great job. Fantastic job done by these colleagues in just 2 weeks. In the conclave, we'll have a couple of lectures by Professor Kalmarkar and Mr. Dash, and then we'll have a panel discussion where the Vice Chancellor of Shiksha Foundation and the university will be participating along with other colleagues. And then in the afternoon, we will have a couple of presentations around research topic or research papers or some more. So this year, we are happy to have only with this, maybe in the coming years, we will try to do it in a much bigger way, I will say. It's done fantastic way, but maybe in a bigger way where really more participation from industry, more participation from startups will be coming up. So with this introduction, let me welcome you all to this one research conclave. Please enjoy the day, participate with all members, enhance your academic activities, enhance your knowledge. Thank you so much.
Thank you, sir, for the warm welcome address. We will definitely keep up the good work. Now, may I please take this opportunity to invite our guest of honor, Dr. Iiit Bhubaneswar, to please come to the podium and address us.
The dignitaries on the dais and members of the audience. Since I am going to get 45 minutes to address all of you, I'll keep my this particular address very short. I am very happy to be here at Iiit Bhubaneswar Uh, the previous triple IT to which I have been for giving talks was triple IT Kanchipuram. And I have also been to triple IT Jabalpur. Uh, I see from the details given here that this initiative is to foster and encourage research mindset in tandem with industrial technologies. So talking about research, there are two aspects. One is discipline specific and other part is discipline independent. So when we talk about research mindset, it is discipline independent aspect that we are talking about, in my opinion. There is a quotation which I am very fond of sharing with my research students. It is not the gun, but the hands behind the gun which win the war. No, it is not the hands behind the gun, but spirit in man which wins the war. I feel this is applicable for research as well. You may have very good facilities, but facilities alone will not give rise to high quality research unless the hands which are working and the minds which are working with those facilities, they are imbued with research mindset. So we must understand what is the meaning of research mindset. In very simple terms, MTech, a master's degree, can be regarded as an advanced version of bachelor's degree. However, research is not an advanced version of MTech. Many students who take up research are under that impression that just like MTech is an advanced version of BTech, PhD is an advanced version of MTech. This is actually not true. Research is very different from MTech or BTech, which is course-based education. And therefore, it is very important to know the difference between course-based education and research. If we understand this properly, then we will do better research. So it is very nice that you are organizing a conclave like this, in which I feel we should focus on both these aspects, that is discipline independent of whether you are doing research in humanities or metallurgy or physics. There is something that you require as a researcher. So we should focus on that as well, apart from discipline specific aspects, like you are working in semiconductor technology, nanoscience, or maybe water conservation or blue economy or whatever. I think with those few words I will stop and again connect with you in my lecture. Thank you.
Thank you, sir, for the motivating talk. We learn a great deal from you. Thank you for inspiring us. Now, I'm delighted to request our guest of honor, Sri Devesh Das, to please come on the podium and address our students.
Good morning to Platy. Good morning, my dignitaries here, Ghosh sir, Sarkanti sir, and Kamakar sir, and all my other maybe friends, teachers, and sometimes my students also, right? Many of I was just trying to reach to multiple faces to recognize if I can recognize, because I used to visit IIIT at least once in a year. So already we have a relationship. Maybe that has started from the day when we started coming to your campus from IBM, and I was representing earlier. Yeah, it is one good opportunity not to be here, to talk to you, to understand the ongoing activities within IIIT, and sometimes we need to know, right, how we are upgrading ourselves in terms of curriculum, in terms of facing the industry's need. That is very important, because you all knew how the industry is looking for the resources now. So research conclave, I assume the research conclave definitely will conclude some sort of, conclude with some sort of message that all the fellows, all the research fellows, they should, take it and practice in further life. You might have completed your research year, maybe, already getting your award, but you have to keep it up going forward. You have to continue, as Karma Prasad mentioned, right? So different ways, different objectives you have to have during the research. I might have not done actually proper research, but I felt in my career many times it started with a deep dive. If I'm not doing a deep dive, I don't think your mindset will, go into that level, right? Ready-made technology, ready-made, process, steps, which is available. Maybe sometimes we used to, follow that overnight. Sometimes, there is a standard practice nowadays. Like people used to just see and then replicate. That's okay, because business also needs that sometimes. But at the same time, I think my request will be to all of you to start with deep dive and follow some methodology to do the research. Then you will definitely, come out with a proper outcome and you will be satisfied. So thank you all. With this, maybe in the further session we'll discuss. Thank you, sir.
Thank you, sir, for motivating us. We will definitely give all our efforts to make this event a grand success. Now we take extreme pleasure to invite our chief guest, Honorable Minister Iiit, Sports and Youth Affairs, Home State Government of Odisha, Shri Tushar Kanti Behera. Sir, please come on to the podium.
Respected Director, Iiit Bhubaneswar, Dr. Ashish Ghosh. Respected Director, Iiit Bhubaneswar, Dr. Sripati Karmalkar. Respected Mr. Devesh Das from IBM. All esteemed professors, faculty members, researchers, students, and distinguished guests. A very good morning to all of you. It is truly an honor to stand before you today as the chief guest for this research conclave in our Information Technology Unitary University. Research is the cornerstone of progress, and events like this provide a platform for the exchange of innovative ideas and the fostering of intellectual curiosity. First of all, I must congratulate Iiit Bhubaneswar for celebrating this Research Conclave 2024 to celebrate the day of 20th January, because Iiit Bhubaneswar got its university status on 20th January 2014. I commend the university for fostering an environment that encourages curiosity, exploration, and collaboration. Your commitment to excellence is evident in the quality of the research being conducted within these walls. The convergence of diverse perspectives and expertise is what propels us forward in our quest for knowledge. In the realm of information technology, we find ourselves at the forefront of transformative trends. The rapid pace of technological advancement demands constant exploration and investigation. Your presence here today reflects your commitment to pushing the boundaries of knowledge and contributing to the ever-evolving landscape of IT. Today, I am particularly thrilled to address a topic that is not only critical for our technological advancements, but is also paramount for the well-being of our planet, that is sustainable technologies. In an era marked by rapid technological evolution, It is imperative that we, as stewards of innovation, embrace a vision of progress that is in harmony with the environment. Sustainable technologies characterized by their eco-friendly design, energy efficiency, and minimal environmental impact are the need of the hour. As researchers and scholars in these interconnected fields, you are at the forefront of shaping the future of technology. The fusion of electronics and electrical engineering with information technology and computer science offers a unique opportunity to pioneer solutions that not only enhance efficiency and performance but also contribute to a sustainable and greener world. Consider the possibilities of energy efficient computing systems, smart grids, optimizing electricity distribution, or the development of environmentally friendly material for electronic components. Your collaborative efforts can lead to breakthrough that redefine the technological landscape and set new standards for sustainability. To the researchers, I encourage you to channel your expertise and intellectual curiosity towards projects that align with sustainable goals, collaborate across disciplines, share your knowledge, and explore innovative avenues that bridge the gap between technological advancements and environmental responsibility. To the students, you are the architect of the future. Embrace the challenges of incorporating sustainability into your academic pursuits. Your fresh perspectives and creative thinking can pave the way for solutions that not only propels into the next technological frontier, but to do so with a mindful consideration of our ecological footprint. I commend the organization for choosing such a pertinent theme for this research conclave. May the discussions and collaborations that unfold here lead to discoveries and innovations that not only advance our technological capabilities but also contribute significantly to a more sustainable and resilient future. Thank you, and I wish you all an inspiring and fruitful research conclave. Vande Utkarja.
Thank you very much, sir, for the wonderful address. Your talk is timely and relevant. We truly treasure your association with Iiit Bhubaneswar. We are extremely grateful to the honorable dignitaries for the kindly consented to join us in this occasion. We are glad that the man is time for us out of their busy schedules. To convey our gratitude, may I please request our director, Iiit Bhubaneswar, Professor Ashish Ghosh, to please honor our esteemed guest with a memento and traditional uttarias as a token of appreciation. I request our director to felicitate our guest of honor, Shri Iiit Bhubaneswar. Can we have a big round of applause? I request our director to felicitate our guest of honor, Sri Devesh Das. Let's have a big round of applause. Now the most awaited moment. I request our director to felicitate our chief guest, Shri Tushar Chandri Behra. Let's have a big round of applause to celebrate this moment. am glad to share that Joint Secretary of Sports, Government of Odisha, Sri Kailash Das, is here with us today to encourage us and support us for this research conclave. May I please request our Registrar, Iiit Bhubaneswar, Professor Devasis Jena, to please felicitate Kailash Das. Let's have a big round of applause for the Thank you. Let this research conclave culture the vision and mission of Iiit Bhubaneswar to impart world-class education and train the young generation to lead the economy and the society in the coming decades. Our commitment to the value chain of knowledge creation, diffusion and preservation will definitely result in bringing concrete solutions to the contemporary global challenges. Now may I please request Dean Academics, Iiit Bhubaneswar, Professor Rakesh Chandra Balwant to please propose a vote of thanks.
Good morning, everyone. Respected dignitary on the dais, off the dais, my faculty colleagues, dear students and participants. It has been an honor to be part of this event, Iiit Research Conclave. On behalf of Iiit Bhubaneswar, I would like to extend my heartfelt gratitude to our esteemed guest, Sri Tushar Kanti Behera, Minister of Electronics and IT, Sports, Youth Affairs, Home, Government of Odisha. Mr. Devesh Das, Technology Practice Head IBM, Dr. Sripad Kamalkar, Director IIT Bhubaneswar, Dr. Ashish Ghosh, Director Iiit Bhubaneswar. My sincere thanks to our Registrar Professor Devasis Jena, Chief Coordinator of this event Professor Pradyut Biswal, and as Sir has said in the inaugural speech, three of my faculty colleagues, Dr. Arun Sahu, Deepak Raut and Mr. Sarthak Padi, they have worked really hard to make this event a success. Last but not the least, I would also like to thank all my faculty colleagues, PhD scholars and BTech students who have contributed directly or indirectly to make this event a grand success. A wide round of applause and thanks to all the participants who have come from outside the institute to also make this event a grand success. Finally, I would like to thank all of you present here for sparing your time with us and to make this event a grand success. Thank you one and all.
Thank you very much, sir. Now we may proceed for the invited talks, followed by a panel discussion on the emerging technology for a sustainable tomorrow. Thank you, esteemed dignitaries, for being with us. It was a huge pleasure to have you with us. We truly pleasure to contact with Iiit Bhubaneswar. I request our audience to please be seated. We'll now proceed for the conclave, the invited talk and the panel discussion on emerging technology for a sustainable tomorrow. We'll start the session in a moment. And to coordinate the session, I'd like to request Professor Bharati Mishra to please come on the stage and proceed further.
नेम नहीं हटाना और किसी का लगाना है क्या
A very good morning. Welcome you back to this technology inverted talk session. I am Professor Bharati Mishra, Department of Computer Science and Engineering. I welcome you to this Research Conclave 2024. Already Deepika Madam has enlightened us the reason behind this celebration. On this auspicious occasion of our university, our college Iiit Bhubaneswar converted from a college to a university status by Government of Odisha on 20th January 2014. And it is our privilege that we have become a university. And I am proud to say that I am the first batch of PhD scholar from this university. And from that day onwards, our university has marched forward, and many students of our university has reached to the globe and are pioneering in different fields and taking the lead in different technological areas. To commemorate this celebration, we have this our director, mentor, Professor Ashish Ghosh has introduced this Research Conclave 2024, and to celebrate this, we have many eminent speakers from the various parts of the world. Already we have got a glimpse of our speaker, that is our Dr. Sripath Karmalkar from Iiit Bhubaneswar. He has rightly said it is not the gun, not the hands, but the mind behind that is the actual thing that is will count in winning the war. So I would like to invite Dr. Sripath Kamalkar from Director Iiit Bhubaneswar. He needs no introduction. He is a visionary, a leader. He has received his BTech and accelerated PhD degrees in electrical engineering from the Indian Institute of Technology, Madras, Chennai in 1983 and 1989 respectively. He has held visiting research teaching assignments with the University of California and Rensselaer Polytechnic Institute and the University of South Carolina. His areas of interest include semiconductor devices and education. He has authored video courses on solid-state devices, semiconductor device modeling, and introduction to research hosted on YouTube. His recent research has focused on modeling and simulation of power devices, GaN, HEMS, nanowire devices, and solar cells. He has received the 2006 Vikram Sarabhai Award for Research, 2007 IBM Faculty Award for Research and Teaching, 2021 VLSI Society of India's Best Faculty Award, and President's nomination to the IIT Council. He is an associate editor of IEEE Transactions in Education. I welcome you, sir, to enlighten our students, our faculty members, and guide us how we can go ahead in the research directions. As already we know that every seed has a potential to grow into a tree, but how that seed will grow into a tree unless it gets a platform. That platform is it gets appropriate air, temperature, and soil and water. Similarly, all of us we have the potential to lead the world. But how we can do that unless we get a platform? And this research conclave is such a platform where the gurus will handhold the students, the disciples to lead the society. Like Arjuna has the potential to win the world, but he could not do that unless Guru Drono has trained him how to do the war, how to win the war. So like us, we have a guru, a visionary, a leader, Dr. Sripad Kamalkar, who will guide us how to do the research, how to go ahead in life and do some contribution to the society to have a better sustainable life. I welcome you, sir, for to have a enlightening talk.
Can I request those who are at the back to please come here so that I will be a little free to move and speak.
Hello.
I think I hope I'm audible. Yes, sir. Yes. Even to those who are at the back. So, as she introduced me, I have interest in semiconductor devices. Hello? Yeah. Semiconductor devices and education. And I mentioned in the introduction that related to research, you have two aspects. One is discipline independent, whether you are a metallurgist, a humanities person, or a physics person, anyone. If you are a researcher, you need a certain mindset to do research. That aspect is as important as the discipline specific aspect, which may belong to humanities, metallurgy, or whatever. So I have two options here. I will choose one of these two depending on your choice. So a discipline specific option, my area, there is semiconductor technology. It was mentioned in the introduction by one of the speakers that Odisha is is helping in a big way in the semiconductor mission. In fact, Odisha government has the best semiconductor related policy in the country as a state to attract semiconductor fabrication facilities, and I already know that a couple of people are almost they have almost decided to open fab in the InfoCity too. So that is why this is one option I have, personality of semiconductor technology. It's a popular level talk, independent of what your discipline is. I can talk about what is unique about semiconductor technology. That is one option. Another option is discipline independent. As I mentioned again in my welcome address of what is the difference between course-based learning and research. So from the audience, I will first take a feedback, which one they need. Since my interest is in education, I know that it is very important for the speaker to be connected to the audience. So I will simply ask for raising of the hands. So let's take, how many of you would like me to speak on this? Only one of these two I am going to do. So how many of you would like me to speak on difference between course-based learning and research? Please raise your hands. Okay. How many of you prefer this one? So I see that there are less hands for the first one, right? So I will go with the second. So what is the research mindset? We need to understand. So I'm going to talk about this. So let us quickly define what is research. Before that, I should I should know the background of the audience. How many of you here already hold a PhD degree? Please raise your hands. How many of you are working towards a PhD degree? How many of you are neither working towards a PhD degree nor have a PhD degree? So I think it's almost equally divided. Okay. So those who raised your hand now, who are neither doing PhD nor have a PhD, can you tell me what are you doing? Your bachelor level students. Okay. Fine. Even then it is fine, right? This discipline independent. So what is really research? research, I am going to be very practical here. Research is a work done to find a question and its answer and publish these findings. In one sentence, if somebody asks me to define what is research in very practical terms, this is what it is. There are 4 words here which are important. The work, what question is the work trying to address? What is the answer to that question? And whether this entire thing is published or not. If any one of this is missing, it is not research. For example, somebody has a good question to work on and has good answer but has not published. It will not constitute research. Right? So why? We'll see that. But let us quickly complete this definition. What are the attributes of these 4 words? Question should be relevant and significant. This is the attribute. Every question will not mean you are doing research. Okay? Is it relevant and is it significant? Answer. Is it original and is it useful? Just originality is not sufficient. Just utility is not sufficient. Okay, both. Work. Does the work demonstrate above average skills in surveying literature, thinking, communication and management? There are the 4 areas in which the work should be above average. Okay? Now, this is where I am going to show you how research is different from either BTech or MTech. You want to pass a BTech or MTech, right? If you get, let's say, about 35% marks, you can pass, right? You can go out. This is a time-bound program. 4 years, you can come out if you get more than 35%. That is the rule in each subject. Okay? Maybe in some places it is 40%, it could be, whatever. But research is not like that. It is not exactly time-bound. Unless you have work that demonstrates above average skills in surveying literature, thinking, communication and management, it will not constitute research. It will not, you are not ready to write and submit a thesis. That's why you will find some people doing PhD for 4 years and some doing for 7 years. Right? Why is it like that? You can't say the person who is taking 7 years is less competent than a person who is doing for 4 years, who has taken 4 years to do a PhD. Okay? So there are differences. Also, the work should follow a sound methodology. For example, it should be scientific. So what is the meaning of scientific method? That also I should understand if I am a researcher. Whether I am a humanities person or an engineer or a physicist, chemist or mathematician, I must know what is the meaning of scientific method. Then the publication, it should pass through a peer review. If you publish something in a newspaper or publish something in a paid journal where you pay money and then it will be published, it will not be counted as research. What matters is what is the quality of peer review that it has undergone before publication. Okay? So this is what basically research is. You can go to finer levels like surveying literature includes your skills in ability to search for material, collect material, read and also know. There are the 4 things that you must be good at. Thinking, it includes logical, analogical reasoning, analyzing, imagining, designing, interpreting, reorganizing, comparing, evaluating, all of these. Communication includes oral and written, both. Management includes interpersonal relation. You can get a BTech or MTech degree all by studying all by yourself. But if you want to get a PhD degree, you must at least be able to work with your guide. It's very important. Many times the PhD doesn't work out, even though you do hard work, you are intelligent, still it doesn't work out because it didn't work out with your guide. So therefore management of interpersonal relation is important. Time management, stress management is also important. Why? Because what is PhD? It is you have to focus on one idea for a very long time. This ability to focus on one idea for a long time is has been identified as one of the major sources of stress for a PhD person, for a researcher. Apart from, of course, broken relation with the guide. They are the true main stress points for a PhD student. Then resource management. So what is the meaning of scientific method? In your work, there should be a clear distinction between what observations you made and how you made them. What is your explanation of the observations, that is theory. And what is the method you are used to verify the theory. These things should be very clearly indicated in your thesis. If you look at it, look at research as a process, then how does it look like? So first step is you get selected for PhD or MS through an entrance exam, and then next thing you do is meet your guide or advisor, fellow students and staff. Why have I put this here? Because many times research scholars are not aware that the quality of research they do depends a lot on their relationship with these people, which may not be that much important in BTech or MTech. Then you choose a research topic, and after you've chosen a topic, you start with questions. This is another important point I want to emphasize. Many times you ask PhD students what is the first step for research, they will say literature survey. Actually, that is not correct. First step is raising a question. This is a very significant point about research. While, as we will see, BTech or MTech, your grade point average in BTech or MTech depends largely on how you have answered questions set by the teacher. Research depends on what questions you have asked. Totally different. That is why many times what happens is, because we are not aware of this difference, we regard one degree as an advanced version of the other. Suddenly when you come for research, you find things are not working out. Because we are not aware of the difference. Once you are aware of the difference, you get oriented properly. So research starts with questions. Therefore, one of the skills you have to develop is how to ask questions. What is the meaning of good question? How can I enter a new area by asking questions? People have this doubt that if I don't know an area, how can I ask questions? Right? Actually, to enter an area, you have to ask questions. This is what you learn in research. So once you learn this, actually at the end of PhD degree, in principle, you should be able to enter any other area by using the skills that you acquired during PhD. So after you have raised questions in your mind, now you start your survey to answer those questions. Now please remember, when I say question, this question is not the same as the question on which you might submit your thesis. Please understand that. When I'm talking about questions, start with questions. Right in the beginning, you may not be able to get a significant question on which you will start working on for your thesis. Right? That is it's coming later. I'll come to that. But before doing any literature survey, you should always have questions in the mind. Okay? It is exactly like, I give an analogy. Suppose you are let into a room like this and you are told, please explore this room. And then write a report. Alright? Another option could be, I can say that I have misplaced a needle somewhere. Please locate the needle. Right? And the level of attention to various parts of the room will be much higher when you are trying to locate a needle than you are told, please explore this place. Okay? The same is the role of question in research or in literature survey. If I don't have a question in mind and I am reading a paper, then it is not possible for you to focus because the paper is talking about several things. So how do I acquire all of this? But if you have some questions in mind, when you look at a paper and then you raise some questions and then you try to find those answers, what will happen is you will read everything very carefully. Automatically your attention level will be higher. So it is a skill. As I said, like cycling, if somebody shows you a single wheel cycle, you will say, how to ride it. First time you try to ride it, you will fall. Right? But after some time, you can get the skill. So that is the way it is. That this is a skill that you need to acquire during your PhD, during your research. So after you have done literature survey, during literature survey, more questions will come up in your mind, and then you will think over them. So periodically, maybe once in 3 months, at least, I'm saying at least, you must hold discussions with your guide or fellow students, and you must also make a presentation. This is very important. Many times research students say, my research is not progressing. But they don't know how to progress. Because they feel unless you get an idea in the mind, your research is not progressing. So no idea is coming up in the mind. So now how do I get ideas? You start from there, right? People have this problem. So this is the way to warm up your mind to get ideas. Please understand this. It is like boiling water. You want, when do bubbles start in water? When you raise temperature, beyond a particular temperature, suddenly a lot of bubbles will come, right? Same way here, unless you warm up your mind sufficiently, you won't get ideas. Okay? So this is the way to warm up your mind. So read, after reading, raise some questions. Automatically your questions will be raised in your mind. You think over them periodically. So maybe once in a month, have a discussion. Simply, for discussion you don't need ideas. You have done something for 1 month, you have read some papers, some questions arose in your mind. Just make a summary of all of this. And then you discuss. What is the difference between discussion and presentation? Discussion doesn't require much prior preparation. It is spontaneous. Okay? But presentation requires arranging your ideas in a logical order before making the presentation and removing what is unnecessary, organizing your thoughts. Okay? So even to make a good 20-minute presentation, you might spend 6 hours. So that process is also very important. That is why discussion will be more frequent, presentation will not be that frequent. But if you do a good presentation in front of even 2 or 3 people, okay, during the process of making a presentation, apart from the preparation that you have done to make the presentation, during the process of presentation itself, sometimes ideas will strike you, right? And then you might get a solution to your problems also. So out of this, then comes a research question. This is a major question that I said it is significant and it is relevant. Such a question comes up in your mind. You may also call it as an hypothesis. So now, once this has been, you have hit upon this, then you start verifying the hypothesis, parts of the hypothesis, and then publishing, part by part. Okay? And after you have published a couple of good papers, you can write a thesis. After you have written the thesis, it will be sent to reviewers, like with any paper, right? Publication requires review. As I said, attribute of publication, it should go through a peer review. If it goes through a good peer review, then the publication that comes out will also be good. It may be rejected, your paper will be rejected, you give some comments, you work on those to improve your work, right? And then finally it gets published. So thesis also goes through the same process. So final step is defending the thesis. The reviewers would have raised some questions. You have to answer those questions. They might have raised some, they might have made some criticisms. If the criticism is not valid, you must be able to defend yourself against it. If it is valid, you must change your work, as well as your thesis. And finally, then it gets submitted. That process is called defense of the thesis. So this is the whole process. Let's briefly touch upon what research is not. A good way to understand what something is to also know what something is not. Okay? Research is not merely collection of information, data, or description of a topic. Many times the word research is used loosely, even for if I collect lot of data. Then I say I have done lot of research. Instead of saying I have collected lot of data, I will use the term research. I have done lot of research. That's not correct. Collection of data is part of research, but research is more than that. Similarly, description of a topic. You write a good textbook. It is not research. Why is it not research? Because it doesn't satisfy the criterion that it is new. Please understand. Everybody knows these concepts. And maybe little bit here and there your explanations are different, but it is not significantly new. I am not saying it is not useful. See, research, usefulness and originality, both have to be there. Only then it is research. So, description of a topic, even though it may be good, it may be lucid, alone does not constitute research. But rather, it is a new observation or correlation, explanation, analysis or interpretation. That newness is very, very important. And or a new position that you wish to argue about or defend. Okay? So let me illustrate this with an actual an anecdote which actually happened. So what you see here is the last step I mentioned in the previous slide. That is defense. This is defense. So this is what is going on here. This is a research scholar. She is the guide, and this person is the reviewer. Reviewer has given some comments to the research scholar, and research scholar has gone through those comments, and finally the presentation. This is the final step. Presentation where the research scholar is responding to the criticism of the reviewer and so on. So this is what is defense. Now, in one such thing in a North Indian university, some exchanges between the research scholar and the reviewer happened in Hindi. So I'll first tell in Hindi because sometimes when you change the language, you lose the impact. But I'll also translate in English for those who don't know Hindi, right? So what happened is the reviewer was telling the research scholar, look, the strengths of your thesis are that you have meticulously collected a large amount of data. You have spent a lot of time in building the apparatus. You also you have presented the data well in the form of graphs and so on. But where I have a problem is in your interpretation of the data. I am somehow not convinced with the interpretation, what you are giving, right? So because of that, some repeated exchange was happening. So the research scholar at some point told the reviewer, देखिए डेटा लेना हमारा काम है, इंटरप्रिटेशन गाइड साहब करते हैं, आप उनसे पूछिए. So in English, translating in English, my job is data collection. Interpretation is done by my guide. Kindly ask. Okay. Now this is where the problem is. Why the quality of research is not good or quality of research scholars is not good. It is because of this misunderstanding. Research is not an assistantship under a guide. It is a process of becoming an independent thinker. This is a very important point. Research is not assistantship under a guide. BTech project, it is to a large extent assistantship under a guide. MTech project, to a large extent assistantship under a guide. But PhD is not assistantship under a guide. It is a process of becoming independent thinker. That is why raising questions, trying to answer them, trying to find explanations is research scholar's job. Then people wonder, then what is the guide doing? Only getting credit, right? For what the research scholar is doing. To some extent it is true, but there is a significant role for the guide, where you come up with a question. Is it significant enough for PhD? You may not be able to decide. Okay? How relevant it is, you may not be able to decide. The guide has to give you guidance there. Suppose you have an answer. Is the answer technically correct? You need to discuss with someone, right? So that is where again guide comes in. So there are various places where you must remember that the two words control and guidance don't mean the same. Control and guidance don't mean the same. BTech and MTech, these are course-based degrees. They are controlled by teachers. They're controlled by teachers. They decide the curriculum. They give the question papers. They decide the syllabus. Everything is controlled. You are supposed to answer the questions, right? So it is controlled. Guidance is different. What is the meaning of independent thinker? You are doing everything. Guide. The word guide means you have to be guided. No, you are going in the wrong direction. Please go like this. That is what is guidance. So the entire initiative is with you. So now let us distinguish between objectives of degrees. namely course-based education research. What is the difference in the procedure adopted in this educational, in this curricula, PhD and course-based, and what are the evaluation criteria? How they are different? So, objectives of degrees. Bachelor's degree, the objective is general education. That is why it is not a good idea to do lot of courses in one area in bachelor's. The goal of bachelor's should be to expose yourself to various topics. In spite of lot of pressure, that is why BTech in artificial intelligence, in my opinion, is not a good option. Focusing on one area for bachelor itself, because there is a lot of demand, right? That's not a good option according to me, right? Because a BTech is general education. However, MTech in artificial intelligence, fine. Because masters is possession of advanced knowledge. That is the goal. What is the goal of PhD? License to teach and guide others to become professionals. See, this we must remember. Many times, research scholars are not aware of this particular thing. What is the goal of PhD degree, right? That is why what happens is, supposing they are asked to do teaching assistantship under the guide, to handle a few classes, tutorial classes, correct papers and all, they feel it is taking away time from research, right? It's actually not correct. It is very important. Every research scholar should do teaching assistantship. Okay, that is handle tutorial classes for the teacher, correct papers and all this. In the process of doing all of this, your subject knowledge and understanding improves a lot. Plus, you learn how to guide others, right? How to guide others. MS degree can be regarded as equivalent to 50% PhD. By MS, I mean by research. MS degree by research. Masters by research, not masters by coursework. Okay, that's the difference. So these are course-based, and this is what is research-based. So now let us quickly form a table to distinguish between the two procedures for various aspects, such as prescription of courses, teacher prescribes courses, research and learning, student identifies courses. That is why, if you join a PhD program, it's not a good idea to go to your guide and ask, sir, what courses should I do? Then what should you do? Please remember, it is a process of becoming an independent thinker. You should think what courses you should do. Write down, these are the options you have. Then go to the guide. Then tell the guide, sir, I think these are the courses I would like to do in my PhD. Then the guide may say, no, I think this course is not good. Maybe you should do this course and so on. But it is not correct to go to the guide and say, sir, what should I do? This should never happen in PhD. PhD, whenever you are going to the guide, go with something. Always go with something. To do something yourself and go to the guide and then ask, sir, is this okay? What should I do next? This is the crucial difference between course-based education and research. Only if you follow this approach, you will become an independent thinker. Otherwise, you will remain an assistant. Let us look at reading. Read textbooks or class notes. That is sufficient to get good grade point average. In fact, there are many students, they only read notes. They don't even read textbooks. They read notes and they get good marks. Right. But what do you need to do good research? Extensive reading of books and papers, hundreds of pages, beyond one specialization. You want to do good research, you actually have to be willing to read little beyond your specialization. Because what are new ideas? New ideas are transplantation of existing idea in a new surrounding. New ideas are transplantation of an existing idea in a new surrounding. So many times you actually can get good ideas by going out of your field and reading up or understanding something, and then you will find, oh, if you apply the same thing here in your field, right, you will get a novel solution. Let me illustrate this with an example. Atomic structure. There is a nucleus at the center and electrons revolving around it. How did this idea come to the scientists who proposed? The idea came as follows. The macro universe the macro world, the bigger world, they found is arranged like that. Sun, planets revolving around it. So some scientists got this feeling, if the macro world which I am able to sense with my eyes and so on is arranged like that, something in center and other things revolving around. Now I have the micro world. There are some observations. I want a theory for it. Can I develop a theory by assuming in this small world also there is something in the center and some other thing revolving? If I have some such structure, can I explain this observation? So the idea of an atomic structure in which electrons are revolving around the positively charged atom actually came from the idea that there is sun and planets revolving around it. So transplantation of an existing idea in a new surrounding, that is what is a new idea. A lot of research has been done. They have found this is the way new ideas come, by analogy, right? So that is what is meant by reading beyond one specialization. Now the point arises, when I'm not even used to reading a textbook, how will I suddenly be able to read papers? Textbooks are generally well written. Papers, unfortunately, are not well written. It's not easy to read papers, right? That is where one of the problems is not good communication. Okay. Now you have to read hundreds of pages. How to do it? In this context, I want to share an anecdote again. Swami Vivekananda, apparently, he was a voracious reader. So from the library, he got a book which was so thick. After a week, he returned the book. The librarian asked him, "Did you actually read the book?" He said, "Yes, I have read it." Librarian said, "No, I don't believe. Same book, so many people have taken, who are also recognized as good readers, and they have kept the book for a month or two before returning. You are saying within 7 days you have read. How is it possible?" The answer he gave is very important for a researcher. He said, some people read word by word, some read line by line, some read paragraph by paragraph, some read page by page, and some read chapter by chapter. So what is the meaning of this? When you say you are reading a paper, doesn't mean you are reading every word of it. That is why I told you in the beginning, what is the way to read? You have a paper, you have a title, you please raise some questions in your mind, and then you try to look for answers to those questions. Okay? So what is the way to read hundreds of pages? In fact, in my course I normally do, you can do this exercise if you have mobile phones. How to read a paper? You please do Google search. How to read a paper, right? And you will find material. One example of how to read a paper is read the title, think whether it answers your question. I have told you already, you should have a question in mind. If it answers your question, then read abstract. After reading abstract, you get a slightly better view of the paper. After reading abstract, you feel yes, likely to have the answer, read conclusion. Shift to conclusion, read the conclusion. After reading abstract, conclusion, title, you feel it might have an answer, then read all the figures, only figures. After that, you get even better idea. You feel there is an answer, you can directly go to the location where the answer might be there. You don't have to read the whole paper. But if you are not able to find, then you start reading from introduction and so on. So this is the way the paper should be read. You can do a Google search, how to read a paper, or speed reading. So you have to develop this kind of reading skills. That is the only way you can do literature survey and read lots of papers. This is what is different between research and course-based education, reading habits. Now, as I mentioned, it includes reading about the research process as distinct from discipline-specific data concepts, such as a talk that I'm giving. It is not dependent on your discipline. It is about research. This is what is meant by material about the research process. So another assignment I give my students is, again, Google search, you and your research. You type you and your research in Google. I will pause for a minute. And as soon as somebody gets that particular article, tell me who is the author. You and your research in your mobile. As soon as somebody has it, raise your hand. Yeah.
Richard W.
Yeah, Richard Hamming. So he was a scientist in a lab that is well known for major discoveries which have revolutionized electronics. You see here, transistor. From where was the transistor discovered? Bell Labs. So Richard Hamming is a communication expert. He used to give a talk, a discipline independent talk on what is research, how to do research well, to all the new entrants into the Bell Labs. So that is the talk. I urge all of you to read. He discusses things like what's the meaning of good thinking, right? What is the meaning of a good problem to work on? How much time you should spend in developing your presentation for an idea. You want to prepare a presentation, 20-minute presentation. How much time you should spend? According to him, 50% of the time should be spent in preparing how to present. 50% of your research time in how to present. Okay? We don't have time here, otherwise, usually when I conduct a session, a workshop, I give time, so 5 minutes time, you read. Nowadays, searching is very easy. You put the search, presentation, you put that word and you locate that sentence which says how much time you should spend in presentation, right? In course-based learning, ready acceptance of what is taught, seek small clarifications. Please recall, in school or in BTech, who are regarded as good students? Who are regarded as good students? You ask teacher, please identify some good students from the class. Those who readily accept what is taught, they grasp quickly. And they ask a small clarification. They should not ask too big questions that rattle the teacher. No, then the teacher won't like. Okay? That's generally the norm. But research quality depends on ability to raise big questions. That is where the research differs. The research question guides and centers your research. Course-based learning, you need to study for a few hours at a stretch to write an exam. But here, arduous persistent study for a few years. You know, PhD duration, as I said, average is 5 years. Okay? So, it's like a marathon. Course-based learning, you take lab, collect and interpret data to support established laws. All of us have done labs. We already know what is the data we want to collect. If you plot a graph, how it should look. Right. That is why, what do you do if your observations are not fitting into the thing? Now everybody is fighting, right? What do you do? Adjustment. You do adjustment, right? That is why, even though we have done so many labs in school and in college, why we are not developed the scientific method is because of that. It's because of this adjustment. Because you know the law already. Whereas in research, you have to collect and interpret data to verify new hypotheses. You have a new hypothesis. Now you have to collect data and see whether the data fits into this hypothesis or hypothesis fits into the data, right? That is the correct way of putting it. So now what happens is, you have to be very sure whether your apparatus is giving the right reading or not. Because you are not sure what will be the hypothesis, what will be the law, right? Unless you are sure of your measurements, no errors, no systematic errors, no random errors should be there. Otherwise, you do not know what it should be. So there is no scope for adjustment, right? So this is not easy. Imagine you are setting up a new experiment which nobody else has set up. It is giving some readings. How do you know? Your readings make sense, they are meaningful, right? So it requires a high level of experimental skill. This is what is called experimental skill. That is ability to judge whether your data is free of systematic errors. Whether your data is free of systematic errors, right? You are standing on a weighing machine, it shows some weight. Is that weight correct? Is that weight correct? How do you know? Right? I'm giving a simple thing. Like that, in When you're doing research, you will have questions. So collect and interpret data to verify new hypothesis. So each of this is a 1 hour session, right? Give examples of how a student collected data, how the student adjusted data during PhD. So what was the result, right? And if you don't adjust that data, what is it that you have got? With examples, right? Now, course-based learning, you have to solve problems. Research-based learning, you have to formulate problems. Course-based learning, you have to write examinations. You have to evaluate others' work. Literature survey, you have to evaluate others' work, whether it has gaps, is it accurate, and so on. Course-based learning, you can do all by yourself. Research-based learning, work with guide and fellow scholars. I already mentioned about this. Here, again, I want to repeat. Each of these, you can spend an hour. I have done this. I talk about what are the problems in guide-student relationship, why they arise, and so on. And every time I have done this course, I have done in Raman Research Institute. I have done 80 such sessions. I am just naming a few of them. Raman Research Institute, then IIT Bombay, and so on. Every time I have done the course, at the end I will get one email from some student. Sir, I am having problem with my guide. Can I discuss with you? Then I have an online meeting. Okay, then I ask them to tell the problem like a doctor, and then I give diagnosis and then give solution. And I have also saved emails. After 2 months, they will send me an email. Sir, now it is all working fine. Okay, so each of these is important for research, for success in research. Finally, now let's come to evaluation criteria. How the two are different. Time-bound examinations, 1 to 5 hours. That's the maximum time. I want to know from people here, anybody has written an exam that duration was more than 5 hours. If in open book exam, it goes beyond 3 hours. But I have not seen more than 5 hours exam. But here, it takes 3 to 6 years. In course-based learning, problems are same for all. You can go and argue for marks with the teacher. I didn't get 1 mark here, you can go and argue. But in research, there is no, the reviewer is anonymous. And the problems are different for different people. So comparison also is difficult. You can't compare. That guy got 89 out of 100. You got 85, you're not happy. You want to see where you can adjust, where you can gain more marks. But research is not possible. There will be some student, research student, who will get one paper. You will find him writing a paper at the end of 1.5 years. And at that time, you find your research question itself is not framed. And then your mind starts thinking, that person is doing experimental research. See, it's all easy for him. The apparatus is there, you churn out data, and then you just write, okay, I'm doing theoretical work. Unless I get an analytical solution, I cannot publish. Analytical solution is very difficult to get. I should have taken this experimental thing. I did a mistake by taking up theoretical. Suppose you are doing experimental work, other one is doing theory. You find at the end of 1.5 years, that person is writing a paper. Then your mind works. See, my thing, I have to go to workshop, get this thing fabricated, and when I get the readings, I am not sure whether the readings are correct or not. That guy just comes, sits on the table, works with a computer, one pen, that's all, and does online reading, because nowadays people don't even go to library, because everything is available online. And then at the end of 1.5 years, writing a paper. I should have taken a theoretical thing. This experimental thing is very complicated, clumsy. So the grass looks greener always on the other side. This is the problem, because problems are different for different people. This is where your guide again can be of help. When your mind is going through these kind of ideas, the guide has more experience, he will tell, okay, 1.5 years you haven't got a paper, doesn't mean anything, right? Your paper may come after 2.5 years, but after that you may get 2 papers quickly. That's why research, you cannot compare very easily between 2 people, okay? You can't easily say a person who has published 2 papers is worse than a person who has published 3 papers. You cannot say like that very easily, okay? It takes time to know the impact of research. Solution, there is one correct solution to a problem generally. Here, there is no one correct solution. So all you can say it should be new and original, there can be several solutions. In one situation, this solution is better. For another situation, another solution may be better. To write the solution, it takes up to 20 minutes and 4 sides of A4 size paper. Please think whether you have written an answer to a question in an exam that goes to more than 4 sides of an A4 size paper. Whereas here, your writing may take more than 6 months and take 100 to 200 sides of A4 size paper. That's your thesis. So your communication skill has to be much higher. The solution is submitted to the teacher. It is submitted to an international journal or conference. Teacher, you know, right? Reviewer, you don't know, anonymous. And one reviewer may say your work is good. Another reviewer may say I don't find anything new. You will wonder, hey, how two people can say such contradictory things about this? That is the nature of creative work. Creative work, somebody may say it is good, somebody may say it's not good. That's the nature of creative, all creative work. Subjective. The evaluation of creative work is subjective. So it is not objective. I'm almost coming to the end. Results are declared in a few days after the exam. Your review of a paper or thesis may take 6 months to 1 year. Pass marks more than 35. Paper or thesis acceptance is based on newness, originality, truth, accuracy of data, scientific technique, whether the methodology adopted is scientific or not, how good is analysis, and what is the quality of your writing, the thesis, communication. Based on all of this, your thesis is accepted or not accepted. Whereas more than 35 you get, you pass in course-based education. Okay? So I think with that I want ended. I'm only quick illustrations. So what is the problem in guide-student relation? In PhD, start of the PhD, the relation is like this. End of PhD, it is like this. In other words, research blurs the distinction between the guide and the student. Research blurs the distinction between guide and student. Doesn't happen in course-based education. They're always like this. They're always like this. Teacher is always there, student is always like that. Then you have to avoid unjust comparison. I have told problems are different for different people. You can't compare very easily. And you need to develop a neutral or detached attitude to success and failure. You should not be excited when you're writing a paper because it might get rejected. Okay? At the same time, if it is rejected, you should not feel like this. Because research is a story of mostly failures, dotted by few significant successes. It is mostly a story of failure, dotted by few significant successes. Okay, I think with that I should close because 45 minutes exactly. And these are all illustrations of the same thing in a diagrammatic form. I will go to the end. So if research is all of this, somebody might say it is so painful. No, it is not. Here are some feelings expressed by research scholars after they got their degree. During research, the feelings of exploration, excitement, challenge, involvement, and passion are frequent, and one gets an enormous feeling of achievement on the award of a research degree. Yet another person said, I discovered my own self during the research process. Self-discovery. Okay? So that is why it is worth doing. It is worth doing. Yeah, I think with that I will close. In case you have one or two comments or questions, I'll be happy to. Anybody has any comment or question? I'm sure you have. Yes.
Very nice presentation. And my name is Sanjay. Actually, I just wanted to ask.
Can you also tell what you are doing?
Actually, I'm a faculty here. I'm working in the area of data science in healthcare.
Okay.
So I just wanted to ask, how can we inculcate the habit of reading among BTech students or MTech
Very,
students?
very nice question. Very good question.
Because we are living in the era of artificial intelligence.
Yeah.
Everything
Can
is
be done.
available on our fingertip.
True.
So students.
That I know. It's you have raised a very good question. So let me, since you have raised this question, let me please sit down. data has shown, take example of Hungary. It has many Nobel Prize winners in different fields. What is the number of libraries they have per 1,000 people? Israel, also number of Nobel Prize winners. What is the number of libraries? And what is the reading rate? It has been shown, generally Asian population, the number of books they read in a year is the minimum of all. In Hungary, Israel, I'm giving some examples, you can take data. Data is available on this. So, you want innovation. You want innovation in society. It is directly linked to reading. Clear, scientific correlation. So, what we have to do is, first we have to tell this to students. You have to alert them. I'm not saying just telling this, people will suddenly start reading. No, I'm not saying that, but you have to build up. First, we also should be convinced that it is worth spending your time. How to make people read. Then, one should, once this awareness is there, how things can be different. See, I have been in my school, in all the classes I was topper. I used to get a book as a prize in annual function. But no teacher ever asked me, have you read the book? I still remember. I used to get the book and keep it. Only my father would sometimes tell, you people, you are not doing any extracurricular reading. You are not reading that book. Those books which have you read? Only my father would tell sometimes. No teacher ever asked me, have you read the book? You tell a summary in the class. Something, right? No. So I feel there is it is necessary to have awareness among the teachers. That reading is really important. Using such things, data, you provide data about this. How innovation is linked to reading habit and so on. Then, at least the student to whom you are giving a prize, a book as a prize, ask that person to give a talk. You can do this. So we should have sessions like that to make people read. Organize talks and so on. So, in fact, I have done serious thinking on it. So, in Iiit Bhubaneswar, we are working on a course based on all these things what I have said, Introduction to Research and Innovation. So, the way to do the course is, don't give lecture. I am telling how to make people read. Don't give lecture. So, let us say reading. One session is on reading. What you do is, you ask people, you give reading material to the people on reading. You give reading material such as this statistics about how reading is correlated to innovation and so on. But be reasonable. If a person who is not interested, who is not used to reading, if you give a thick book like this and say you please read, it won't work. So you have to be practical. You give 10 pages of material about what you should read, how you should read. I told you how to read. It is available in internet. How to read a paper, so on. What to read, how to read. Give material. Ask them to read this. Then we are going to introduce the course shortly. Ask the students to come and organize discussion. So make groups of 4 where the students are from different disciplines. Not the same discipline, different disciplines. Let them discuss about this reading material. What are the important points and so on. After they have done the reading, you ask each student to make a 7-minute presentation, PowerPoint presentation, on important points. In their own way, let them make a presentation. Right? After they have made the presentation, ask them to write a 1-page summary of the reading itself, what material. Like that, we would like to do for everything. Thinking. For research, good thinking is important. What is the meaning of good thinking? To give some reading material. Ask them to read. Let them discuss. Ask them to make a presentation, small presentation, 7 minutes. Then write 1-page summary. Like this sequence of reading, discussion, presentation, writing. Repeat for every important skill that you want to develop for research. So this is I'm giving a practical way how we should be doing if we want to develop some skill. This applies to reading also. Any other question?
Sir, I have a question.
Yeah,
Sir, I am Anjali. I am from Computer Science Department.
faculty.
Sir,
You are a faculty?
yes,
Ah.
I am leading the Computer Science Department.
Okay.
Sir, actually, my question is a bit different in the sense that mostly we are, like our institute, it is mostly academic oriented in the sense of teaching institute. We are not purely research institute.
Correct.
So most of our time is devoted to teaching. So in that scenario, how you can motivate the faculty as well as the student for pursuing good research in the true sense of the term, and how do we motivate our students to go for research instead of going through placement, earn and lead a decent life. So it is difficult to convince students
Yes.
to
So-
stay back and
Yeah, for everything, that is why I developed interest in education. As I would have told you in the beginning, I have equal interest in semiconductor devices and education. Because I have discovered this is actually a challenging thing. In research, you take some problem and like sustainable, how to have a sustainable ecosystem, you are thinking and then suggesting. Like that, about how to motivate students itself, you take as a problem, right? And analyze scientifically what are the ways different people can be motivated. How to put a program in place that will increase motivation level of students. You have to think research from a research perspective, right? So that is why I am saying my suggestion, practical suggestion about this is all students should undergo a course on introduction to research in the way I have told. That is the way to actually develop. Because research on learning has shown very clearly that only if the learner is made to do activity, the learning is deep. Only if the learner is made to do activity, it is deep. Just by lecturing, people don't learn. This is very clearly established. That is why modern pedagogy suggests all courses to be taught in an active learning mode, in which the classroom arrangement itself should not be like this. The classroom arrangement should be a round table with 3 or 4 students sitting like this, movable chairs. The entire classroom should be like this, and all your material should be organized in terms of short talk followed by activity. Talk followed by activity, and collaborative activity, in which discussion, communication happens in the class. Class is not purely to listen for 1 hour. No, some classes may be like that. I am just telling, some classes may be purely, if you are doing highly abstract course, maybe you have to spend a lot of time in imparting the concept. But you have to introduce more of activities. This is a way to transfer learning into a student. This is the key point. If you ask what has the research on learning shown, this is the key point it has shown. You must change your method of running the classes. So in Iiit Bhubaneswar, we have actually developed just now, last month, 6 classrooms which are all arranged like this, with round table and chairs. And now we want to motivate all teachers, so we are going to see how many hours a teacher is doing classes in that classroom. That is one data that teacher has to, because how to motivate the teacher, right? It's not only how, it is about how to motivate anyone, right? Motivation is the most general thing. So they have to prepare a teacher portfolio in which every semester they have to log in how many hours and when they have handled classes in that kind of room. What activities they have done. It is important. So when people come up for promotion, we will see that. Just like you are seeing what are 2 best papers. What are the 2 best papers? What is the quality of that? So we will try to assess the quality of teaching in terms of these parameters. So that is the way we are trying to do it. Implement this first among faculty and then it will get translated to the student. So I will end because I think time is going on. About reading. Just one more thing I want to share. Personally, how I develop reading habit. Right? In BTech, I am a BTech from IIT Madras. In third year, I found all my friends preparing for GRE, graduate record exam, because they want to go abroad for research. There, you have to write 3 exams: quantitative, which is simple mathematics, analytical ability, and then verbal. So everybody would buy a guide in which previous papers were there, and then do an exam to see what are your scores. So when I did that exam, for me, I got good scores in quant, mathematics, and analytical, but I got poor score in verbal. I got 45 out of 100, whereas my classmates, they were scoring 95 to 99 in verbal. Okay. My grade point average was among the top in the class, but my verbal score was low. Then I was wondering, why is this verbal important? And then I read up why verbal is important, and then it was written there that achievement in life, in scholarly domain, is important. Achievement in life in scholarly domain is linked to the vocabulary you possess. This vocabulary develops only by reading. So, by trying to see what vocabulary you have, you can assess the scholastic potential of the person. I didn't know all of this. And when actually I scored 45, and then, you want to also try for going abroad. So that made me, so how to develop vocabulary? Then there were methods suggested. So one is you read books on psychology. Second, you read newspaper daily, and you read the editorial of the newspaper daily. By reading the newspaper, you learn how to construct sentences which are of correct length. The newspaper, if you see carefully, doesn't use very long sentences because it should appeal to an average person. And editorial of the newspaper, it has a good language. You develop vocabulary, you read editorial. So all those methods. So I did all of that, and then I got interested in reading, right? Then I understood why it should be, why it is important. So like that, one has to motivate, give data, tell practical anecdotes, why it is important, and then So maybe you do all this for 100 students, 10 students may develop, but that is still an achievement. Okay, I think I should stop. Thank you.
Thank you, sir, for igniting our minds. You have told what is research is and what is it is not. And also you have told as an educator, as a teacher, how we can motivate our students to get the reading habit, to do the research, and how to think, and how to deliver something which is useful. Only research in its domain cannot do justice to life, to the world. So we have to bring the research to the industry, to the lives of people. So to enlighten us how we can carry out a research and bring it to the industry level, we have with us industry expert, Mr. Deves Das, who will be delivering the next thought-provoking lecture. He is a practice leader and account executive in IBM India. Mr. Deves Das is a renowned name in IBM India, currently serving as practice leader and account executive. He has received his PGDCA from Star International, where he has also served as consultant. His long career over 25 years include tech lead at Metal Star Information Technologies, tech lead at CFCI, IT manager at Huntsman, cluster service delivery lead for Microsoft Tech, and his current role of account executive at IBM since December 2015. His work at Microsoft Technology encompasses capability building, resource pooling management, technical solutions, defining service delivery frameworks, and enabling SMEs, to name a few. Now I welcome you, sir, to the dais to deliver a lecture and enlighten us about your experiences.
Thank you for the questions. I would like to thanks Mr. Karmakar first, because I was just trying to map, because I'm not a research fellow, but I was just trying to map many points that Sir was mentioning in a structured way of doing research. Most of the time I am into delivery. I was into client facing role, where you don't know what client will ask you to deliver or provide the solution. Sometimes they expect then and there you should give a solution. You have to do a magic. And many times I face that type of situation, and I was thinking, why this type of expectation is maybe from the brand name that I am working for. When client used to see, right, oh, it is IBM, people comes from IBM, that means they know everything. You ask anything, they will solve it, and they can do the magic. That type of pressure came, but yes, that has pushed us sometimes to think. When I say think, this particular term you might have got from our brand, right? Think bad, think book, right? So think, we used to push that into the employee's mind always, and I don't want to say that we pressurize the employees to think, but we facilitate employees to think, right? And when I was comparing with the points that Sam mentioned, yes, unconsciously maybe, when we are delivering the work as a consultant, we also do some sort of deep dive. Right, deep dive is required. If you have not done earlier on a particular topic, then you have to do sometimes. So you should know, how to do that, how to manage the time, and finally, because in that time the problem statement is there already, right? So you have to come out with a solution. So I will share some of my experience, because when we want that, how this research should play a better role in the industry. Of course, it is very required, right? Most of the large or prominent companies in IT industry specifically, you see, they have their research unit. Why they have the research unit? They can easily get the resource from the market by putting an advertisement, openings, right? But that is not really going to solve. And all are not going to invest on that level, right? And it needs a huge investment. I don't know other companies how much they declare their investment towards research, but in my organization in IBM, I have seen 6.5 to 7 billion dollar type of investment in a year they invest on research. They put on the research. Then we used to think from the consultant's point of view, what they are doing. Why is lots of money is going there, but it is not reflecting in our salary, right? But it has its own requirement. It has its own viewpoint. It has its own value, right? We are just learning a particular technology and implementing it. An idea jam, and make sure that your each and every resource from your team is coming up with some new ideas, and those ideas has to be properly recorded and Then the next step is the ideas has to be converted into, solution related to the business you are working for the client, and then it should be converted. Finally, it should be converted into dollar. That is business. Then I was thinking, why should I kept to this role? I was doing good coding in different languages, and it was a cool life. Uh, Visual Basic, sometimes C, C++, and all those we were enjoying. And then I found, yes, it is too difficult actually, and I didn't know that how to do it. Then I was just roaming around like what to be done. Then started learning some documents from the organization that they have shared. But I found some IBM fellows there in Pune. In from India also we have a big number of IBM fellows. We hardly met them. Many times they used to be isolated themselves into different locations. Maybe earlier it was only Delhi and Bangalore, and now we have a center in Kochi. So they're just doing all those. But I found one person who is younger brother of Mr. Kejriwal, and he was just sitting quiet and kept some of the achievements, details in his face, and only was concentrating into something. Then someone told he is one of the research fellow. Then I went and checked, and I found yes. Then I went and met him, and I requested him that help me in this scenario. Right. So we arranged some sessions. I found he has shared some of the good ideas, like how people have to think, how the resource has to prepare themselves to put the hand into this type of war. It should not be just previous day go to Google and search something and come back to the delivery next day. It is not something like nowadays people are talking about ChatGPT. Everything you will get from ChatGPT, so nothing to be done, right? So why should I put some time? It is not that. People have to do deep dive, right? Even if you are learning a particular technology, and if you have interest towards that, then you need to put more efforts. You need to raise more questions, as I have mentioned. Then you have to come out with different solutions based on the situation, which might be fit for different situations in your client situations, and that is required. And we arranged a couple of sessions, not couple of, maybe 3, 4, 5 sessions, and then he could not get more time, but yeah. So then we took it ahead. And later I shared that experience with our top management also, and I found they have put it in a best practices going forward. Every department, every practices are nowadays getting a chance to listen from them, either directly or video, virtual, right, clips. That is going on. It's a very important thing, and the patent counts and all, it is increasing like anything. Of course, in 2022, IBM patents became 50%. Like earlier, it was consecutive 9,000 plus type every year and in worldwide. But in 2022, it came to 4,000 something. It has some cause, but again, organization has not accepted it, that cause, just because pandemic it has happened and all those. But no, it is not necessary that people have to only come to office and do their research. Not necessary, but yes, it has some environmental impact, and that might have people say that, but that might not be the accurate answers. But again, it is. I think in 2023 onwards, people are putting more efforts to that, and they have got more scenarios, they have got more demands, they have got more challenging situations, and when AI came to picture, and open AI came to picture, right, and specifically quantum, IBM is putting huge investment on quantum computing, around 12 billion plus type, right? And when all those, and cyber security is now a real challenge, right, for all of us. So when those came to, came to us as a demand, like, we have to put more efforts, more time and all, then I think this scenario will change now. Almost all, techies, they are putting time into that. And yes, many of our developers, they comes with a challenge. Sir, I want to do research. Put me into India Research Lab. I cannot work here in this business because always I'm getting calls from client and I'm not able to concentrate. I don't know how to give the resolution or solution on that. But yes, I used to suggest them that you have to invest more time other than your delivery. You have to put more time on learning. You have to put more time on deep dive, right? Then only you can do. It cannot be either or type. Otherwise, you put your own effort, do all the learning, resign from this particular business unit, and you can appear into research lab and join there. That can be another way. But doing both, like someone was asking the question now, right? In this current scenario, people are looking for job, right? Post BTech, they are going to campus and looking for job. How they will do the research? If job is necessary, yes, take that. But on top of that, you have to find the way. You have to find the time. How you will do the research. And once you are into that field, and I believe most of the organizations are nowadays supporting to help them, right? To take them into that particular path, career path, and we all should leverage that way. Yeah, thank you, sir. So here, when the question comes like what industry wants, industry obviously, the focusing points nowadays. If you ask anyone, they will start talking about AI, right? They'll start talking about cyber security. They'll start talking about machine learning, right? And on top of that, as a IBMer, I can say always like, quantum computing. Right. These are the top, you can say, in demand areas now. People are putting more efforts. So doing research on those areas it is also recommended in IT specifically. I am not pointing out any because always we need many research on nuclear area and Sarah's better ideas on those to share. But as I am from the consulting background from IT only, my focus is going towards that only, right? And yes, in quantum computing, I have seen some of our junior resources. Those came out from the college maybe before 2 years, right? And they have shown interest and they have done all the learnings, initial learnings, and after that they appeared some of the assessment and moved into that because that also needs some more deep dive or deep learning, correct? So that you have to invest for you. It cannot be just I got a chance in campus through 3-4 types of assessment. Maybe it is writing code and analytical and reasoning and all those. Then I'm ready to go for research. That is not it. And my organization is also having different type of different level of hiring. Sometimes they used to hire for research directly. I don't know, in Bhubaneswar might have not. I cannot recall. I don't know if people are coming to IIT Bhubaneswar or not. I have no idea on that. But it has, they have their own different way of hiring into different business units. And we might call some of the fellows and to Bhubaneswar. I'll look into that to arrange some of the sessions, right? And I will request most of you, those are doing PhDs are already completed, they should also look for some of the opportunities. And on the research area, I'm sure they can also leverage those benefits. I'm not telling in Bhubaneswar might be possible, but yeah, pan India, anywhere it is possible. Correct. And industry needs perspective. My suggestion will be to focus on AI, and within AI now there is a flow. Now within the IBM organization, I have seen mostly towards generative AI, right? And like Microsoft is focusing on their open AI and Copilot products and all those. You will find in many Microsoft products the Copilot is already embedded, right? So we are also working on generative AI, huge investment, and IBM is focusing basically not to just release, that to the market where people will exploit it, right? ChatGPT and all those people are exploiting also, right? But here our focus is to come with a good governance, right? So AI governance. The AI governance will be adapted to country level laws, their policies, right? Because it will be implemented finally in the business, right? So it should not happen that you are using generative AI and it is not accepted for a particular country, right? And there is a challenge, and then lots of things will come in between, difficulties, legal issues and all those, right? So we are first focusing on the governance, data and AI, of course, three things within the generative AI, and coming out with some of the foundation models, right? Now, before 3 months, I think, we started a huge drive to Pan India, or I can say worldwide, IBM, where our Watson supercomputer, right, as now embedded with AI, they came with a new name, Watson X, right? So when it is Watson X, then it was pushed to all of us. Learn that, try to know or explore it. What is your Watson X data, AI, and governance, and then start developing some of the foundation models. Because initially our researchers has came out with very minimum number of foundation models, but it has to be expanded, right? So this is a big area now. People are putting more efforts into that. That is one area I saw. And yes, quantum computing, it is going like anything, because IBM is now planning to come out with all the applications, tools to say it is any process related to that, so that it can be used by normal user or businesses, right? So for that we have to probably come up with a quantum supercomputer type, right? That is the target that IBM is focusing on. And in the other companies, in the if you compare with the as a whole IT industries, I think mostly same, right? AI, ML, cyber security, which is again a very challenging thing. But cyber security, I think those challenges will be solved better, or efficiently, quickly, when this, your processing and all will be faster, right? Quickly. So maybe quantum computing will help a lot on that, right? But we cannot just keep it aside. Please do some more research on those area, and that is also needed the hour. But once the quantum computing is available for all of us to use, maybe on that time we might get some good solutions and quick processing, because it needs huge amount of data to be processed, right? And faster. Otherwise, it will be for no use, right? By the time you identified that pattern and try to trace the leakage, so many loss has been made by that time, right? So that is what another focus I found many of our forum they used to discuss. And yeah, so nothing much, because Sir has given all the points in a structured way, how you will do for your research, the difference and all those. I also enjoyed. I think you people have also enjoyed. And from the IT industry perspective, this is the need of the hour. And I was thinking to talk about the methodologies that you should follow during research. I think mostly Sir has covered. And yeah, thanks for your time. Thanks for listening to me.
Thank you, sir, for enlightening us not only to do research, in what are the cutting edge technologies like the quantum computing, the cyber security, the generative AI, and allied areas. Now we'll move forward to a panel discussion. The topic of the panel discussion is emerging technology for sustainable tomorrow. We are living in this world with 8.1 billion population. The natural resources are depleting at an alarming rate. There are climatic changes, which is a major concern for a sustainable life on Earth. To empower our future generation to lead a sustainable life on Earth, we need the help of emerging technologies that will help us in efficient resource management, disease prevention and cure, adapt to climatic changes, and moreover, leading a healthy physical, mental, and spiritual life. In 2019, we didn't know that we are going to be hit by a pandemic which will jail us in our own homes. Thanks to the video conferencing tools that kept our kids' education going on, patients' counseling continued over these tools. Moreover, the conferences, symposiums, spiritual congregations went online. This technology sustained us through the pandemic. We don't know what challenges our future generation would face ahead. But we need to create technologies and use them effectively to sustain and face the challenges gracefully. To shed light on those technologies, we have experts from various fields as panel members to discuss on this topic. Now I will invite the panel members. As a moderator, we have Mr. Jyotirmay Rath, Executive Director, Iiit Technologies. I welcome you, sir, to the dais. Mr. Rath is a seasoned leader with 22 years of experience in healthcare and insurance technology industry. In his role as delivery manager, he has owned delivery responsibilities, multiple complex programs spanning across cloud migration, digital transformation, legacy modernization, and platform migration initiatives. As part of his current role as Executive Director, Delivery and Center Head of Iiit, he strives to create a community of passionate, purpose-led individuals
Because once you start this, it gets extended. It is half an hour, 40 minutes, but it
business challenges.
Sir, you want to leave or?
Next, we have as a panel member Professor Pradipta Kumar Nanda, Vice Chancellor, Sikya Anusandhan University. I invite you, sir, to the dais. Professor Nanda graduated in electrical engineering with honors from the VSS University of Technology in 1984. He received the master's degree in electronic system and communications from NIT Rourkela in 1989 and the PhD degree in computer vision from IIT Bombay in 1996. He is currently serving as the Vice Chancellor of Sikya Anusandhan University, directing the research in image and video analysis. He has delivered several invited lectures, published 86 papers in various journals and conference proceedings, authored 5 research books and 7 book chapters, and supervised 4 doctoral students and 45 master students. His research interests include image processing, analysis, biomedical image analysis, video tracking, computer vision, subcomputing and their applications, ad hoc wireless sensor networks. Dr. Nanda is a fellow of IIT India, a member of IIT UK, and a life member of IST India. He received the Bharat Jyoti Award from the Indian International Friendship Society in 2012 and the Odisha Technocrat Award from the Evergreen Forum of Odisha on Engineers Day in September 2013. He is currently the chair of IEEE GRSS Society Kolkata chapter. Then we have its panel member, Dr. Devi Prasad Das, Senior Principal Scientist, IMMT. I welcome you, sir, to the dais. Dr. Das received the BSc Honours degree in Physics from Utkal University, Bhubaneswar, India in 1996, the MSc degree in Electronics from Sambalpur University, Burla in 1998, and the PhD degree in Electronics and Instrumentation Engineering from National Institute of Technology, NIT Rourkela in 2004. Presently, he is a senior principal scientist at CSIR IMT Bhubaneswar. He is the head of process engineering and instrumentation department. He is the nodal scientist of Jigyasa program of CSIR IMMT and also hold as honorary position of associate professor or ASIR in the Faculty of Engineering Science from April 2014. He has completed guidance of 6 PhDs and 5 are continuing. His research interests include active noise control, adaptive signal processing, computational efficient and hardware suitable algorithms, microcontroller based system development, image processing for the mineral industry, instrumentation, plasma spectroscopy, machine learning, big data analysis, IoT, and cyber physical systems. Dr. Das was a recipient of Odisha Young Scientist Award 2004 by Government of Odisha, India. CSR Young Scientist Award 2009 by CSR India and Boy Scout Fellowship 2009-10 by DST, Government of India, NI Engineering Impact Award 2014, the AICTE INE Distinguished Visiting Professorship 2018. He is also selected as Mentor of Change for Atal Tinkering Lab in 2018 by Niti Aayog, Government of India. Next, we have as a panel member Dr. Devdut Sit, Assistant Professor, IIT Kharagpur. I welcome you, sir, to the panel. Dr. Sit is Assistant Professor of Electrical Engineering and Artificial Intelligence at Indian Institute of Technology, Kharagpur. He received PhD with highest distinction for contribution to computational medical imaging and machine learning from IIT Kharagpur in 2014. MS in Medical Science and Technology from IIT Kharagpur, India in 2010. BTech in Electronics and Communication Engineering from the West Bengal University of Technology, Kolkata. His research interests include machine learning, deep learning, compute platform optimization, medical imaging, multi-dimensional signal processing, and visualization. He is a senior member of IEEE in 2019, has received the IEEE SPS Distinguished Volunteer Recognition 2023, IEM Distinguished Alumni Award 2022, IEM Distinguished Young Alumni Award 2016, the G Edition Challenge 2013, the Fraunhofer Application Award at the Indo-German Grand Science Slam 2012, IEEE Computer Society Richard E. Mervyn Student Scholarship 2012, Dad Sandwich Model PhD Fellowship 2011. He was the organizing chair of IEEE International Symposium on Biomedical Imaging 2022 in Kolkata, India, and has served as a regional editor of IEEE Pulse 1480. Now I welcome Mr. Gautam Behra as panel member, IT expert from USA. Mr. Gautam Behra has I welcome you, sir, to the dais. He has over 30 years of experience in information technology with the last 25 years in healthcare organization, currently working as IT architect for a leading healthcare organization in the United States. He has done Bachelor's of Engineering in Computer Science and MBA. I welcome you all to the dais and carry on the panel discussion on the topic Emerging Technology for Sustainable Tomorrow. I request Mr. Jyotirmoy Rath, who is the moderator, and the stage is yours, sir, and please conduct the panel discussion.
Am I audible? Thanks for the detailed introduction of the elite panelists that we have. I know you're running a bit late, but yeah, I think with the kind of panelists we have, I'd like to start the discussion. Maybe I'll start with Professor Pradipta sir. My first question to you would be, how do you define sustainability in the context of technology, because when we speak about technology, we talk about productivity improvement, we talk about the user experience, we talk about how to do things fast, but how do you define technology and sustainability?
Thank you. I think, yeah, it's my pleasure to be here in the finalists with the co-panelists and all. As of sustainability definition is concerned, this is kind of the technology which will kind of support the move or kind of the maintain it by a particular process. Could it be economical, could it be financial, could it be societal for a sufficient time. So that should give the sustainability. And if you look at the technology, for example, if I give green technology, is a sustainable technology for, because it's a technology for the sustainability of the future, because that we want. It covers everything almost, kind of, which has impact on the society, impact on the human life, impact also the maintaining the kind of the natural resources and biodiversity, also ecological systems. So therefore, I think the technology which help us in maintaining these processes, those technologies will be kind of the sustainable for the future. Could be whatever now the buzzword is AI, ML also, could be the technology which will sustain for the future.
Thank you, sir. Now, hello. Thank you, sir. That's a great definition. When I was reading recently, now that we are living in the era of cloud, the data center, they produce a lot of greenhouse gas, and that is becoming a big concern, right? So that's a good use case wherein we can use technology to even do some sustainable initiatives. Coming to the next question, I'd put it to Dr. Deviprasad Das. So what do you see, sir, as the most promising emerging technologies in the area of sustainability?
Yeah, there are many technologies which are emerging. There are some existing technologies. Let's say the power generation. So whether we'll be still dependent on the thermal power, or we'll go for renewable resources or hydrogen energy. So if there are energy generation and energy storage, energy transportation or distribution, if we develop many solar based power stations, then what is going to happen when they are obsolete? So recycling of the things are very important. Like our lab, I come from a CSIR lab where there are 37 laboratories in different areas. So we not only work on mineral processing, extraction of minerals, we are also working on recycling of the waste materials, like solar panels to be recycled or the batteries to be recycled. So those type of technologies are supposed to come. Otherwise, any technology you speak, they are going to pollute our environment after some days of use. Therefore, emerging technologies can be recyclable. Any technology which is going to help us for certain applications or certain need, that should not be polluting. Even if it is polluting, then we should have ways to revive that. For example, something is generating carbon dioxide, so we should have a technology to absorb the carbon dioxide and convert the carbon dioxide to again fuel. So it is not only the IT can revolutionize everything, but material science development, new material development, and for using new material development, use of AI ML technique and computational techniques are also very important. So like use of computational softwares for analyzing the different type of material development is very important. So I just picked up a point of the power, that there may be other emerging technologies which other panelists can tell.
Thank you, sir. Uh, Devdutt sir, you are closely involved with the academia and the industry. So what are your views on the main challenges associated with integrating technology into the sustainable practices?
So that's a real challenging question, because in general we look into every single aspect in silos, and that's a general sort of like convenience which we have been brought up. So there's one thing which I always go back and tell my students, and that's how in the recent days we have been starting to look into algorithms in a very different way. So one of the things is that Earth is not something which we have inherited from our ancestors. This is what we are taking as a debt from our children of the future. So the moment you start realizing it, that it's a debt and I will have to pay back, then you start becoming more and more reasonable and more somebody who is cautious about how you are using and consuming it. Now comes the next part, which is people tend to think that things on software, and if you put down a small word called as green in front of it, actually solves it wrong. Now let me give you an example from what I do. My research is predominantly on medical imaging. Now, of medical imaging, everybody knows it. So, I mean, you have MR machines, CT machines, ultrasound, etc., etc. Over there, MRs are the largest energy guzzling devices anywhere you would be actually finding it out. And most of the energy doesn't get consumed in order to image your body, but it gets consumed so that the antenna which is used to create the magnetic field does not just get it does not get down into a thermal meltdown because of the eddy current which it produces. So you'll have a lot of heat dissipation which just happens. So there's a lot amount of energy which goes into just pumping out so much of impulsive heat which generates out over there. And the next part is that what you are generating over there is a three-dimensional Fourier space which has along each axis it has about 4096 components over there. So it's a 4096 cubed space Fourier which you will have to compute. So imagine now the amount of complex valued operations you are going to do in order to do an inverse Fourier transform to get just your image created. So that's a whole data center which just runs over there. Now why did I say all of this? So we generally tend to have this one that when we go and say that this is a life-saving technology, we save lives and everything. So that's like, okay, I did some punya, so I don't need to think about the path. But then there was something which I actually consumed from my future generations. So what did I consume? I consumed a lot of minerals. Most of these are heavy metals which we consume. They were mined down by exploiting child laborers in Africa by terrorist groups. That funded terrorism. That led to geopolitical shift. In the last 2 decades, at least in my school time to a geography if I read, a whole country has vanished. There used to be a country called as Tibet, which does not exist anymore. Now it's China. There used to be another country called as Mongolia, which has just gone. And why has it all gone? Today, if you ask me, then I would say it has gone down because of the greed of getting down of much equitable access to great quality healthcare, fueled by powering a lot of our compute-heavy medical imaging technologies. So I am also somebody who is a conspirator on the crime, if I go forward and say, and so is every single person who does signal processing in this room is also a conspirator of the crime, because you are consuming those metals which are leading to this geopolitical shift. Now this is one side of it, quite a heavy debate over there. Now I'm taking all the blame on me. Coming to the point of what would make it sustainable, if you ask me this, then a major thing which we forget is that we consume a lot of water. We release a lot of CO2. Do we have enough plants, or do we have the nature of plants which are going to consume this CO2 back and trap it back into earth and soil? Do we have enough of mechanism within earth today to get back to revive back the polluted waters? The question is no. And possibly building up vertical walls or putting down wall mounted plants on these beams of flyovers is not going to be a solution. So you'll have to relook into what to do over there. There is a whole set of plants which we are losing out because of beautification and etc. drives. We don't even get back to them. There are a lot of traditional techniques which could be brought down, which we are not looking into it. We are not looking into how can you micromanage treatment of water, segregation of water at sources, and then really look into how you can recycle most and most of this water so that it doesn't get down. And definitely we are not even looking down into that industry which is going to release out the most polluted heavy water over there, which would take another 100 years to get cleansed before it can be potable, is not even thinking of looking into consuming black water under any circumstances. So I have experts from different industries and everybody, and just looking into computing and IT and everything in isolation is possibly not a solution. The solution is that you have to now think that if I am going to run down a fast Fourier transform, what is the kilojoule of energy which I am consuming, and for every single run of that fast Fourier transform, how many kilograms of CO2 from fossil fuel did I actually release it out. The moment we start looking into them, then we will start thinking in a very different way that do I really need to do that click and run this code before I really know what is the whole theoretical implication behind that. Now, that's from the research side of it. Definitely, I believe that there are groups which are doing, industry is progressing out in a good way, and these are coming up on the discussions today when we are speaking as to what are the global impacts over there. It's not things which are existing inside us.
Thank you, sir. Very passionate and real life analogies. Now I'll go to Gautam sir. Gautam sir, my question to you would be, as we embrace new technologies, how can you ensure that ethical considerations are at the forefront, especially concerning environmental and social impacts?
Thank you. Before I get into the answer to the question, let me just describe a little bit about the ethics and also that kind of segue to the bias in AI. If you remember the recent pandemic, after that we got the vaccine, and for the facilitating the vaccine, there was a criteria how to select people who needs the most or who can be given first and later on who can be given, so doesn't need for the need to vaccinate. Here you can take a scenario where like a family and having a person in the family needs a specific because of the person is medically challenged or compromised. At that time what happens is the selection process select that person in the family, but doesn't select all the rest of the family members. So why? Because they are healthy, but they need a vaccine later, at a later time. But what happens if those family members get sick or they get sick due to the pandemic or due to some other reason? They cannot take care of the family member who is already vaccinated, but is like he cannot get sick, but he needs attention or care by the rest of the family members. So people think that by giving vaccine to the rest of the family members is not correct because they are healthy, but they are healthy but they need it. There is a concept of need and want. Do they want? They don't want, but they need it. So in the similarly, when we talk about AI, also we talk about how AI can be also biased. So when somebody wants something or somebody needs something, the AI selection process can be biased. So that way, we need to have some guidelines. We have to make sure that we have the ethical consideration in the forefront, especially when we are considering environmental and social impacts. The first one, I would say that there should be ethical guidelines and framework. Like we have guidelines for everything. Similarly, for sustainable energy or sustainable technology, we should have a guideline what needs to follow. Similarly, like we have a guideline for carbon, exhaust pollution, how much pollution it can generate. And secondly, I'll also have another thing is called multi-stakeholder collaboration. Like when we have a policy, so that the government is involved and the business is involved at the same time. All the social or the normal people are also involved. There has to be collaboration with all these different agencies or people or the agencies, so that way they can have a better outcome of that. And also we have to have an impact assessment. Like before implementing the technology, we have to see how it was running and what are the outcomes. And after implementing the technology, we have to see how it has benefited, so that we can compare that. And also, another thing I could think of is transparency and accountability. And if the technology is being implemented, we should know what the technology does and what is the outcome of the technology. Is there any side effects, or is there any any adverse reactions? So we should know all the details. And also, anything happens, who is accountable for that? So we need to know that. If the developer was developed the solution, or the company who is marketing, or who is selling. So we need to know that. And also we need to know about the privacy protection. So the solution is implemented, how it maintains the privacy of the consumer or the clients. So we need to know that there should be a guideline for that too. And also we need to know how the application or the solution being monitored, and like regarding its performance and the outcomes. And the next one I would think of is the education and awareness. So if the solution or the technological solution is implemented, how we are going to educate the people? And if the company or the provider is implementing that, how is it going to educate the people about that product or that solution? And what are the regular oversight from the government perspective for that solution or the technological solution we are providing? What are the different rules they need to follow? If something goes wrong, who is compensating? And when the company is implementing that, like what are the different steps in it to follow? Like the ones I previously also mentioned, like transparency, accountability, and education, and the ethical considerations, similar things also come up in the regulatory oversight. And another thing I could think of is the corporate social responsibility. Like all the corporations should, when they hire people, they should know that they have hired people having in a balancing system, like not having a type of race or type of privileged people to hire, or having a different like diversification of people to hire. And also should have the open dialogue and the public engagement, so that when we have a different solution, they can have a town hall type of things, where they can go and talk about the product or the solution, so that it can be implemented into society or having a particular outcome of that, so we can benefit the society. Sorry, I'm just kind of a bit disoriented.
No issues. We understand. Next thought from my end to Pradipta sir. Sir, in your experience, are there any emerging technologies that you believe will have a transformative impact on sustainability?
Yeah, I believe there are many. In fact, the buzzword for the last couple of years, the emerging technology are whatever generative AI, IoT, quantum computing, machine learning, and could be, I think, vertical farming, could be green technology, and I think cloud computing, so many, robotics, 3D, 5G technology, 3D printing. So out of many kind of emerging technology which we are now currently debating or currently going out. So there are few who will be actually, I mean, transformation. Green technology is one, which actually leads to the green economy. I think it covers the entire gamut of the kind of the solutions like solar, thermal, energy, which have a actually impact on the ecology, on the environment issues which have been debating, and also climate variability. That's we have been debating quite a bit. So those are the possibilities that yes, they can have a impact on the transformative impact on the society, and which you are driving at, whatever all the EV technology or green technology. And not only that, digital transformation is another one which is also impacting. I need to say that it has access for the health, for the education, for the society. So, and the transformation is visible, and particularly in India it is now visible. So similarly, this kind of digital transformation is definitely will have a transformative impact entirely for sustainability, and we are going to that era. Whether we use this technology for this emerging technology for our sustainability, but nevertheless we'll be using on the platform in the kind of the digital technology or digital transformation. This could be ubiquitous in the society. So similarly, we can think of other kind of sustainable agriculture is one, which is also kind of a sustainable for the future, and it will also meet the so many goals of the sustainable goals of the UN mandate out of the 17 goals. So there are many we can think of, and prominently now the varieties AI and whatever generative AI are the allied things, but there are a lot of challenges as you have seen because it will have a long-term impact, and it will be ubiquitous in all kind of the fields, whether it is sustainable agriculture use AI, could it be IoT use AI, and you can think of cyber physical systems also use AI. So the entire world is going towards that, and this will have a definitely transformative impact. But with the rider that we should address the ethical issues, and also the kind of the challenges, the mindset of the society, the policymakers, and also the people who implement it. And for example, I will give the problem with the AI. The countries are debating on the issues, ethical issues. Deepfake is one of the kind of a threat to us, and how we'll address that deepfake in the AI domain or whatever, deep learning domain. That is a big issue now. So though there are a lot of kind of the rules, but we have to make it address with the riders of kind of ethics, kind of the sustainability, so that it will have a larger impact in transforming the society at a large. Thank you.
Thank you, sir. Very well articulated. I would like to ask Devdut sir, sir, in your area, where in medical imaging or the area that you are working on, so do you have any certain technology that you think is going to transform?
So one of the things on medical imaging is that in itself it's an amalgamation of several things. A larger part is definitely how you can sense something. So you send an energy, the energy comes back to you and you do it. So all things around with energy is definitely over there. Things with radiating systems, so whether radio frequency or acoustics or optical, all of those things are there. And then you have a large part of computing, which essentially is all the signal processing which you do. And over there, I mean, two things definitely which I look into is, one is like how more and more efficiently and on low power can you run those compute. So ability to build better quality memory devices, because it's at the end of the day you will have to store the data somewhere, all the samples, you process on the samples, you have a lot of intermediate storages which keeps on going. And one thing which we know by our current understanding about computing systems is it consumes more energy to store the data and retrieve the data than it consumes to actually operate on a bit by bit basis. So if you can lower that energy, you are actually going to bring down your electricity bills and CO2 emissions significantly. So one of the very promising technologies which I see is what is reprising from somewhere around in the 1950s, which was attributed to ferrite core memory or magnetic memory things. So currently you have all of these newer memory devices coming down on next gen memory, which makes use of ferrous oxides in order to do that. That's cheap, you get it very easily, you don't have degradations because it's already rust. What more can it happen over there. It's preservable over very long scales of temperature. So you put it down from -50 to +80 degrees centigrade and it still works. So you don't have cooling requirements, etc. coming down over there. You're going to make much better quality computers with that, with superior amount of memory which you can store. This is one thing. Next thing is it's a RAM which also behaves like a ROM. You just turn off power, it retains its states. So you don't have a wake up state over there and power consumption. This is one thing which I definitely see. The other thing is that we will require energy. You cannot just go around with that. The more and more we go towards such kind of accumulated technologies which can have much higher energy densities at safer levels which can be compacted down, and if they can be made down with abundantly available materials which we will possibly not run out so easily. So one of them is actually salt batteries. So you can look into them. So salt batteries, the major problem is that people are still working out on how to make it safe. So currently what you have is not on a much compact form factor, you have on much bigger size factors over there. But if you can pull it out, then you can actually run down certain gigawatt level power plants out of salt batteries, and they can be running for over a very much extended period of time. They can become those super accumulators which we are looking at. But ability to bring them down into much smaller form factors, say something like a 1 cubic feet of a form factor, is going to be the next level of solution which we will look at. So these two is definitely what I bet on for the future, where it will be.
Very exciting.
I'd like to add what Sir said, like we in a healthcare organization, we store a lot of images in cloud, and to retrieve those images, and images are, since digitized, it has to be high resolution images, and to extract, and whenever the physician is looking at it or reviewing it, we have to extract immediately, and I think the sustainable technology will help us keeping that speed and the accuracy intact. Thank you.
Thank you. So, Dr. Devi sir, from your field, mostly on the mineral materials, so do you see any technologies that you feel in the future is going to have a transformative impact?
Yeah. Actually, as you know that mineral industries are very energy consuming industries, and many old technologies are being used, like blast furnace and all. So people think of using without coke based production of steel, is how to reduce the carbon dioxide emissions, where all we can add. So what I am thinking is, since it is a IT institute, and there are many people in the ITs and instrumentation or electronics domain, so use of instrumentation, sensor instrumentation for making it automatic and making the exact requirement based operation would definitely help in optimizing the processes in mineral processing, and then we can have use of AI ML techniques, so sensor integration, collecting of data, and then use of AI ML technique to operate it efficiently is going to help. Next is like Industry 4.0 now coming to Industry 5.0, then there is a use of mass customization, then there is a big use of such sensor instrumentation, and because you have to customize the production, not the mass production or same type of items you produce, rather you user specific products you make. Very often you have to change the process. So then if you change the process, industry won't like to change because then they have to add energy to it. So they have to stop and do a new process. So you have to be an expert. So a human operator, an expert, can actually do it by minutely observing it and controlling it. But if we can add the sensors, instrumentation, and collecting the data, and seeing that how an efficient operator is controlling it. So the mind and brain of that the human operator has to be mapped to a computer algorithm, which can be called as AI/ML based algorithm. And then we can see that in a lot of such areas, we can save energies. If we save energy, then we reduce carbon dioxide and emission, and then that is going to be sustainable. So even 10%, 20% in every unit operations, if we can save, then this is going to be a big game changer.
Thank you, sir. Now I'll move to the last segment. As Mr. Devdut sir said, the academia, the industry, they cannot operate in silos. I think that is one of the takeaway that I will take to my team. My question to you, Devdut sir, would be in the context of sustainable technologies. What would be your advice to the young technocrats?
So one is definitely look into the overall picture. It's more important than did I bring down 20% of my compute less? Did I bill my AWS bills 80% lesser or anything? When there are much bigger implications which are going to happen over there, you cannot just remain in silos. The next other thing is that while you're looking at overall, one is be sensitive that there will be challenges which other disciplines are going to face. You will not be always able to solve it out. And while you are sensitive to their challenges, also try to understand their challenges and see to a certain point if solutions which you might have can be planted as solutions over there as well. So this is about the interdisciplinarity which happens. But more and more what we need to engage is in mutually inclusive dialogues, which possibly we are losing out day by day. We don't have thought process, we don't have these dialogues going down in social circles. We don't go to a club now to catch up on, have technology exchange dialogues happen. I mean, these were sort of those golden days when, if you look back into history of how science was happening in India, then one of those older societies around in Kolkata which existed, the Indian Association for Cultivation of Science. So if you look into the history of how ISCS was formed, it was never formed to be an academic institution or a research institution. Later on, post-independent India was going to take up an ownership, etc. came up, and hence DST had taken up the ownership of maintaining. But ISCS was actually a clubhouse of the intellectuals going and sensitizing each other over just a cup of tea. That's how it would happen at that point of time. Significant time since independent. Now that we have become more of what we would call as a young democracy, if we compare ourselves to all the mature democracies of the world, then we have actually lost it out, and possibly somewhere now as a democracy and as a country, we are more engaged in youthful liveliness and more of youthful discussions about what drives you, rather than those deep tech discussions which we used to do, which our forefathers used to do at a point in time. So we have to open up more and more of these kind of venues and say, will your social clubs, like say the Bhubaneswar Club, think about hosting sometime a technology dialogue for the common man. And then why not have everybody come down over there and really come to these discussions, because they will be really lively things. I mean, and get down these discussions as coffee table editions, as books which you go down, as inserts on newspapers, so that can make it more and more inclusive for everybody.
Very, very exciting, and thanks for those insights. Also, Dr. Pradipta sir, you being in the educational institute and interacting with so many students, youngsters, what would be your advice to them as to how they can contribute to these sustainable technologies?
My personal feeling is they should embrace the emerging technology, all the young people, because we are moving from a old era to a new era. And it's not that there is a misperception, I can say, that this kind of technology will help in losing jobs, creating unemployment, social security will be lost. It's not that. It's only the skill set has to change. But the same problem is redefined. And so the young people who are really talented and who are actually have innovation in their mind should use the technology, could it be whatever technology with some writers, so that they can solve this kind of use of interdisciplinary nature can solve the real world problems. So they should rather embrace the technology instead of kind of having a thing, feeling it as a threat, and work on it whatever area one wants, and collaborate with the people, as Vidyut was suggesting, that if you collaborate with the people, then you can solve some of the real world challenges which is happening. And that's happening also now with many young people. And that's very exciting to see. Also, I do appreciate the people who are embracing this and they talk on this. It should not be a blind one, but it should be on a very systematic and very kind of thought processed one, so that we can address the challenges of the society at large, and also it will be sustainable for the future. So this will be my kind of the say for the all young people.
Thank you, sir. Dr. Devi Prasad, sir, any advice for the youngsters as you interact with a lot of scientists, young scientists who join your team? Any advice for them?
Yeah. Advice is I'm little worrying that many people are only following to study computer science domain subjects, and the day is going to come where the core things we are going to forget. You know, vacuum tubes were developed long back and they all are removed, and they say vacuum tube is no more required. But now in high power microwave you require vacuum tube knowledge. So nobody knows in our BTech level, these people, what is vacuum tube, what is grid, what is cathode, and not how much vacuum is required there. But then there are labs, they are still following, because the old scientists, they have trained their young generation scientists and they are still using like our ISR or BARC or Siri Pilani, they require the vacuum tube devices. Like sensors, we do not know, we only require the data, and you bring the data, I will use Python code for deep AlexNet or this net, that net, and get some classification and what is that matrix? Confusion matrix or something I will plot and give it. So, but I do not see, I have never seen a thermocouple. So, if a thermocouple is given, how I will interface to my computer, or suppose I want to automate this room lighting system or the microphone system or audio system to save energy, I can never do. I will only depend on the data, which will come automatically to a server, and then I will keep on searching the open source data and just use it for ECG monitoring or EEG monitoring or some COVID chest monitoring. That is why when we in the lab we see a mineral processing equipment is running, we see why the sound is coming. So this sound may be because of a problem, because of an operational condition. So we should know that if I pick up the sound by a microphone, then if I can diagnose the particular problem through a sound acquiring and analyzing, then I can develop a new instrument which will be patentable and that can be sold outside. So all these core electronics, electrical, how to design a transformer to develop a high voltage so that I can make a ozone generator. So these people nowadays very difficult. Transformer winding also they do not know how to decide the width of the enameled copper wire or what will be the core and all that. So most of the subjects are converted to this thing IT domain. So that is my reference on that. One day is going to come that we all will be paralyzed in the technological domain, and then other countries are going to rule us, and they will give the material, and then we will prepare the solar cell. We cannot design our own material for our solar cell. That is why importance to be given, the restriction on the seats in the computer science domain should be restricted so that more students cannot be intake, and so that it will be balanced, that will be sustainable in my view. So for students, because nowadays ChatGPT is there and many things are there, you try to search and try to understand, and the videos are there. So other knowledge also you acquire even if you are studying in computer science. Think of a real problem instead of a apparent problem, which the problem may come in future. Maybe you say that ECG signal processing and something which will detect something, but immediate problems we are forgetting, and which is really bothering us. So like one example I'm saying now, a lot of people are taking drugs in villages. People are not thinking of their health and so how to control using AI/ML. So can we think something like that? So real problems we have to sort out. That is why multidisciplinary collaborations are required. Like people are saying, collaborations is very important. Only when there are different subjects in an university, then it is possible. If only IT will be there taught, computer science is taught, then it will be difficult. So students should acquire multidisciplinary knowledge along with the core coding knowledge. Because coding is not going to sustain for long time because AI will generate the code. So you say that write a code for doing this, they will generate the code and they will do. So after 45 years of age, you will find that these coders are no more required. So we will be jobless. So unless we have problem solving skills in the real world, it will be very difficult for us to sustain our job even. Technology sustenance is different, but our job will not. So thank you.
Very well said, sir. And food for thought for all the youngsters. Just don't go after. Whenever I interview people, what do you know? They'll say AIML, machine learning. So it is becoming a fad without knowing the core, the fundamentals. If you just go at the very superficial level and just look at the outcomes but not the core problem, I think we'll still may be able to find a job, but later on we'll struggle because our fundamentals are not that strong. So I would like to continue this discussion with such an elite panel, but in the interest of time, we have to wind up. I would like to thank all the panelists, Pradipta sir, Dr. Devdut sir, Gautam sir, and Dr. Deviprasad Das. Thanks for your views and your thoughts. I'm sure this is not just a panel discussion. This is a real problem that we are talking about, as Devdut sir said, like having more discussion, having a view of the big picture, and working in tandem with different groups, not only in silos. I think these are some of the takeaways, and especially for the youngsters. Go to the deep, the root cause of the problem, and understand the fundamentals rather than just be a job seeker, right? So we have to really understand the core, and a situation wherein there are 2,000 seats in computer IT and 60 odd seats are not also getting filled in mechanical or civil is a worrisome trend. So we have to also, as industry, we have to give equal weightage to all the disciplines and have that balance. So with that thought, I would like to thank again all the panelists and have a good day.
I'd like to add for every settling interdisciplinary subjects, like when you try to design a solution, you try to understand also what is the financial implications, what is the cash flow, and or what is the capital expenditure, or what is the policy, government policy it has. So it's better to learn different things like finance, social, economics, and learn about the policies and things like that. So it's not only learn about computer science. Thank you.
Thank you, and we'll wind up the discussion now. Thank you. Thank you.
Thank you, panel, for a thought-provoking discussion and fruitful discussion. We discussed what is sustainable technology and what are the technologies that will be sustainable in future. Not only IT, AI, ML will solve the problems of the real world. We need to solve the real world issues, and we have to do interdisciplinary research. And also we need to collaborate, we need to socialize, and we need to discuss, and we should do sensible computing, not only computing, do sensible computing. And also when we are doing research, only we should not focus on our results. We should think about if I get this result, how it is impacting the other disciplines, the society as a whole. We should do that. With this thought-provoking panel discussion, I would like to thank from the core of heart from Iiit Bhubaneswar, the panelists who have taken their valuable time to discuss with us their experiences, their knowledge, and their wisdom. For this, as a token of gratitude from Iiit Bhubaneswar, I would like to invite our Dean Student Affairs, Dr. Pradeep Kumar Vishwal, to present a token of gratitude. I would like sir to give a bouquet and a memento to Professor Pradeep Kumar Nandan, Vice Chancellor, Shikha University. I would like to invite Dr. Devi Prasad Das to receive a token of gratitude. I would like to invite Dr. Devdut Seth to receive the token of gratitude. I would like to invite Mr. Gautam Behra to receive a token of gratitude from us. I would like to invite Mr. Jyotirmoy Rath, who acted as a moderator and engaged in a fruitful panel discussion. With this, we end with our invited talk and panel discussion. We'll move forward for the lunch. Then we have lunch in the guest house. All are requested to gather there and have a very good lunch. After that, we'll have the poster presentations. Thank you one and all present over here, and thank you the panel members.
देखो ना नहीं चल रहा लॉन्च फोटो हम तो
Hello.